Hello, everybody. Thank you for coming. We are going to talk about a simple design principle that we all know of. And usually we actually practice, but not always. And the reason that we do not always practice it is because it is more complicated than what usually we think. And I'm talking about hiding our implementation details. So let's start. A few words about myself. I'm a lecturer at the Academic College of Tel-Aviv-Yaffo and Tel-Aviv University, a member of the Israeli ISO C++ national body, co-organizer of another conference taking place in Tel Aviv called Core C++, and a meetup group of the same name, and trainer and advisor, mainly for C++. So let's talk about hiding your implementation details. Why? Why is it so important? I mean, why should we bother? There is a keyword even for that. Why did they create this keyword? So it is what makes encapsulation in a way. We want to protect object integrity. You cannot change things that you are not allowed to change. It is easier to use. It improves maintainability and easier to debug. We all know that protecting your members is important. It also serves for decoupling because it reduces dependencies. You're dependent only on what you actually expose. If you do not expose something and the user is not aware that you're using this something, then your object or your type is not coupled with this other type, which facilitates for changes and enhances reusability, because once you are not coupled with another type, you're more generic. You can be used without knowing or using the other type. And it improves testability because in a way, again, you do not need to know about things which are private to your behavior, to your class, and thus you can test components in isolation. So why is it not so simple? What makes it complicated? I mean, put things in a private, right? That's it. We can conclude. Let's summarize. Well, not so. It is a bit complicated. First, because we are lazy. Yes, that's something. And we are not just, lazy without purpose. We are lazy because we want to go on early, or because we want to achieve more goals, more tasks. And we don't think that something is that important. And when I say lazy again, maybe time pressure, and we want to cut some fancy design that we think is not required. And we don't think that something is important because maybe it can actually be public. I mean, I don't know, we will see examples that maybe this can be. And in many cases we say, you know what, even if later we'll decide that we do need to abstract something or to hide it, we can do it later. And the thing is that later, in many cases, is much more costly, is in some cases might be even not possible. Everything is possible, but the time frame might be much longer, and then maybe we'll not do it later. Let me give you an example. What do you say about this class? Do you know this class? Stud pair. We have two public members, first and second. They are public. I mean, they knew what they are doing there, right? I mean, that's fine that they are public. Otherwise, I would have two private members with, let's say, getters and setters. Now, one can say, yeah, they are public, but you also have functions. You can use get and then angle brackets, whatever, okay? But yeah, you still have two public members. And the question is, why is not so good? What's the problem? We'll discuss the problem. Do you see a problem with that? I mean, did you see a problem with pair exposing two public members? I will tell you why I think it is. Even though it seems not to be, but it might be. Because in some cases, we do not realize that we actually expose private details. We have a function, return something. We should return it because we need to allow you to read the properties. Maybe the properties are strings or integers. So we actually return, maybe even we return it as a const. So you actually cannot modify, but we do expose things here. We expose the type. We expose things that later would be hard to change. In some cases, it is because of technical constraints. Did you try to create a factory based on unique PTR, then hiding the constructor in the private? It's problematic because make unique needs to call the constructor. So make unique needs visibility of the constructor. Friendship doesn't help here. And there is a way to do that. But if you just try to put foo's constructor in the private, it would not compile. Now, one can say, okay, so I do have foo in the public. I mean, I don't want users to create foo directly. They should call the create factory method. But I can add a comment saying, don't call the constructor directly, which is good enough. No, usually not, it is not. We prefer the code to enforce things rather than relying on the user to read comments. Because once the code would not compile if you use it incorrectly, it is much stronger. It is designed by contracts. We want these contracts. Because there are trade-offs in some cases. In some cases, I do say that, yeah, maybe I want to rely on interface. Maybe I want to expose an interface and not the actual thing, but relying on interface means virtual calls. And maybe I don't want virtual calls. Okay, maybe there are other methods. Or maybe I do want to expose the fact that I'm using random access container, because you can then use this information and your code, the user code, would be more efficient. So performance-wise, maybe I do want. So in some cases, we think of trade-offs. Maybe the trade-off is valid, maybe it is not. And if it is not, it might be that we do expose something that we should not, and we can think about maybe another solution. So our goal in this talk is to investigate code examples, see how we expose implementation details in some cases, and understand why it is not the best design per case, and propose a better design, which hides the implementation details. Let's start. So let's start with stud pair. I need to convince you that, okay, we will not change stud pair, but maybe if we are writing something similar, we would think about, yeah, let's put our members in their private section always. And again, what makes the fact that first and second are public, what makes it a language accident? Well, if I want to write something generic that works with any kind of pair, which includes any kind of stud pair, but also something that I create which behaves like a pair. Can you think about, we are creating some type. We are not using stud pair. Why? Because we want something that behaves like a pair, that would go to a function that expects a pair. That's typing, okay? And our type should behave like pair. Why aren't we using pair for that purpose? Because our type can evaluate second lazily. So let's assume that we have a type that has first and second, but the type is square pair, let's call it. First is a number, second is the square of the number. Now we can calculate the square ahead, but we're not sure that you will ask for the second. So if we would have functions, we would get this lazy evaluation behavior. With members, you know that with members it is still doable, but much harder. How can we do that with members? I mean, if I want to create my own type that would behave like pair, expose two members, first and second, but would calculate second lazily. How can it be done? Yeah.
Doing the copy constructor and moving up some values from
so I hear something about implementing copy constructor, but eventually a second is a member, a data member. Shouldn't it be calculated ahead? So the answer is proxy. You would use a second, which is a proxy, which is an object, which actually knows that when it is being used, it has a casting operator. and inside its casting operator, it will actually create the value. But we all know that proxies are nasty. I mean, we don't want to end up like a vector of booleans. It's not the approach that we would take initially. The approach would be just use two public getters and have two private members. Now, once pair started with first and second being in the public, if we want to imitate a pair, we are stuck with, okay, we also have to go with two public members. And again, we can play with that, but it would not be as nice as and as simple as two public functions, two public functions in the class. Let's talk about structs. In many cases, we just use structs. And structs in general are not the best idea. I mean, we have an order with a price and quantity, and we start with, it's price and quantity. We just send it to the process that calculates the trades, and eventually I just set the values. I'm even using here type safe for price and quantity, type safety, creating types for price and quantity. What's the issue? I mean, I could have put them in the private and add getters and setters. So the issue is, again, very similar to the pair. Let's assume that at a certain point, someone wants to add some other kind of order. And the other kind of order, this should be a better approach. The other kind of order needs a vector of time points and the price. I mean, I want to pay the price at a certain time, but if this time elapsed, I have another price that I want to use. And the quantity, the entire quantity for the whole order. It might be that I have such kind of an order. Now, the actual API that I want the trade processing algorithm to use is just to check the price. And the price is a scalar. The price is a number at the end. So if I'm using a generic order, I'm saying, okay, I will send you an order. You will ask for the price using a function. You will get the price. There is some kind of internal behavior which I don't want to expose to you because it's part of the way that the order is managed. It's not part of the way that the trading process is running. And then the question is, okay, but if the fields were public to begin with, we have an issue. So if this is a start, this is a better start in order to accommodate the different kind of order. And again, it can go both with duck typing if the function that gets the order just assumes that, okay, order is something that has get price and get quantity, and we're going duck typing, or we can amend the example to use interfaces, and it will behave the same. Do you see the point that I'm trying to shed light on? Starting with, yeah, we do want our data members to be in the private. But if it is just a const member, I mean, a string has an ID. The ID is being populated, is being set when person is born. And you're not going to change the ID, usually. So why should we bother putting that in the private section and providing functions, or maybe a function, just a getter? Why should we? Well, usually in software, anything that you start with, this shouldn't change, eventually may change. So it might be that you start with, yeah, that's the ID, but then requirements change, and the person ID might be his social security number, or maybe his passport. So it might be that the ID is now a more complicated object. Okay, I will just add this object, as you described, with the information, and still, is it const? Well, not exactly. Why? Because when you issue a new passport, you get a new number. So when you issue a new passport, you need maybe to hold all the history of previous passports that this person held. So, so it means that the ID is not const anymore because I may add some information to it. But I'm not going to change the SSN. So there is some, and if it is in the public, and maybe it has public members, public functions even, then I would change something and it is exposed in a way that I don't want to allow it externally. So putting it in the private initially and then exposing only the functions that you allow for a person would be better. Tony Van Herd. Have you heard talks by Tony Van Herd? If not, you should. A koan. A koan is a short story with a moral. And Tony Van Herd came with this great koan about the master and his dog. Are you prepared? Are you ready? It's a short story. So, a master was walking down the street, and he just passed by his student and went in. So the student said, "Master, I'm honored by your visit." So the master answers, "I was out walking my dog." And then the master asks, because he sees that the student is working on some assignment, "Your function, why does it take big common struct instead of just X and Y?" And then the student answers, "Big common struct, BCS is the big common struct, is where we keep X and Y, master." Bark, the dog barks. He's hungry, the master says. "Shall I prepare him food?" the student asks. "No, just open the fridge. Let him take what he wants." Did you get it? Okay, we'll go to it later again. Ahm's law says that anything that is exposed, even if not documented as something that you should use or that you are allowed to use, eventually will be used. So let's assume that I put the idea in the public, or I say in the documentation, you should not assume that this thing is in the public, but you should not do this and that. Eventually, somebody would do this and that. Let's assume that there is something in the public with a name that you should not know about. The name itself is obfuscated in a way that, oh, you shouldn't use it, but somebody saw the header file and understood, oh, there is this thing in the public that I can use. So with sufficient number of users, any API would eventually find itself to be used with all different usages, even those that are not to be supported. Why? Because they are exposed. So let's talk about APIs, including internal API, including between components and between classes. I mean, that's a class of my team member. Why shouldn't I allow the class, because it's your team member, even your class, your other class should not do things with this class if it is not related and should be exposed. I mean, eventually we want to keep decoupling and encapsulation. Studies show that applications tend to use small part of an API. Unused API is much more bug prone because it is unused and then less tested in production, maybe even less tested in testing. When there are too many options, e.g. too many overloads, a wrong option would be selected at some point. I mean, I have 5 overloads for a certain function. At a certain point, somebody will select the wrong option. And it will compile, but would not do the thing that you wanted to do because there is another overload that maybe you wanted. So you have to be lean and mean. Keep your API short and concise. Do not expose something just because you were asked for. I mean, in real life, try to be kind. When you are a programmer, be lean and mean. Somebody asks for another function in the API, you can answer, we already have this one. Yeah, but this one is not exactly what I want. Yeah, you can prepare your arguments and then come to this one. It will work for you. I will not create anything else. Why? Because once I will create something more, you will use it, somebody else will use it. I'm broadening my API, and eventually I'm exposing things that will hurt me, hurt you, hurt the project. Limit your API to what should actually be used. Different users may get different view or copy of the same data, exposing only what is relevant. It is context specific. Something that is reasonably exposed in certain context may need to be considered private in another context. The interface that we provide shall be as narrow as possible. Can we expose different behavior for different contexts? Yes, we can. We should, using all the techniques that we have in object-oriented programming. Interfaces, wrappers. Can we identify different contexts? Yes, usually we can. Do you remember the master and the dog? He's in front of the fridge. I mean, the dog still barks. We are in other place, the dog is still hungry. It continues to act too. Master, though I trust your dog completely, I still got a concern. What's your concern? The fridge engine is in the private. So yeah, you can open the fridge, nothing will happen. The dog will not make the fridge non-functional. I mean, he would just create a mess with the food. It's not the engine. The engine is in the private. I'm not sure that this is the proper answer, or this is what would convince the student. I mean, he's a good student, but he cares for his fridge. So it is context specific. Something may be required to be public for one usage, yet have no reason to be public for other usages. Because if they don't need it, don't give it. If they get it, they will use it. If they use it, they will abuse it. And you should trust no one. You got something. Okay, let's do something with it. No, 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 you shouldn't call this. But it's on the public API. No, but not for you. How can I know? It's in the documentation. I didn't read it. It was not there when I got it. Having things in the private is not enough. Let's take an exercise. Are you ready for an exercise? Okay, it's a programming exercise. So you can program it, you can write it with me. Initialize a map, then pass it in a way such that the values can be modified, but the map itself cannot be modified. I want to create a map, then I want to pass it to a function that the function requirements are that the function may change the values, but the function should not modify the map itself by erasing or inserting new values, okay? That's a requirement. Can we pass the map as const ref? Can we pass the map by value? Maybe we can. Then maybe you will come back and say, okay, these are the things that I want to change. In which case, maybe I would pass const ref, then get back some results saying, okay, this is a small map of the things that I want to change. And then the caller would make the change. No, but I want you to make the change. Otherwise, maybe it is not so efficient for you to create the submap, then coming back to me, then I will do the change. I want you to do the change, but I don't want you to be able to alter the map itself, only the values. Can we do that? What is your proposal for that? What is the suggestion? Okay, let's start with the temp one. Let's have a dictionary concept. Maybe the concept, by the way, the concept maybe doesn't expose. We have, let's assume that we created C+20, we created the concept dictionary, and the concept dictionary does not expose the functions that allow modifying the map, only writing into the map, okay? Would it help? Well, first, this is not what we're doing inside foo. Inside foo, we are calling rectangle brackets, and rectangle brackets can actually create a new entry in the map. So if this is what we are trying to convince us that is the solution, maybe better have a dictionary that does not expose rectangle brackets. But maybe it exposes find. Maybe with find you can do things. But the issue with if it is based on a concept, what's the issue with concepts? Have you been at Dave Abraham's talk this morning? Concepts check that the value that we provide adheres to the concept requirements. It doesn't check that the consumption, the user, is using only the things that are required by the concept. You can do anything. So once I got the dictionary, I can actually use anything, and I actually can see what I get. I mean, I do get here a map. So the entire interface of map is exposed to me. Now, one can say that this is the same as getting an argument in a function, which is not exactly the same. If I am using concepts in order to narrow arguments, I would feel much more safe, much more secure that you will not use things that are not on the concept when the concept is on function argument. Again, if you send something as an argument, and the argument is using, oh, this is the case. You are sending it is an argument. So maybe here it is okay. Maybe as an argument is fine. I adding my go. It's not a return value. It's an argument. I will tell you why. As an argument, maybe we can feel a bit secure. Yes, you can use things that we do not allow. But if during testing I send to the function things that obey to the concept, but do not provide the functions that I don't support, then I will catch you in testing using the unsupported function. So it might be an approach, but it is not as safe as saying, no, you just don't have it. So I'm going with another option of creating a wrapper, okay? Let's create a wrapper. And the wrapper, let's call it const dict mutable values. Is it a costly wrapper? Not so. What should be inside the wrapper? Just a reference to the actual map. I don't know if it is a map or an unordered map, so I would just use template argument. So it's going to be a map or unordered map or any associative container that has the functions that I need. And eventually, this is what I'm exposing. This is what I'm giving you. I'm giving you something that has only the function assigned. It's an overkill. It's a lot of work. We will not do it. But if we do it, we protect our code. We do not allow you to do things that you were not supposed to do. And this is the way to go. I mean, any other thing is private to the type that I provide to you. The only public thing that I want to provide to you is the assign function. And this is public. All other thing is not to be exposed. And when we are talking about hiding your implementation details, it is context specific. The one that created the map is not the one that is consuming the map. So they should see probably different API, different interface, maybe different type. So we're using a wrapper here. Hiding smart pointers and hierarchies. In some cases, the user sees a lot of information, which might be noise, which might be things that I don't want you to deal with either because it will be noisy and buggy, or because I may want to change it later. Let's take an example. This example is based on another talk that I gave on creating math expressions. What don't you like with this example? I mean, I create a math expression with allocations. I have a sum. The sum has two operands. The sum actually sums two operands. The operands in this case are exponent and number. Sum actually can get any two math expressions, pointer to math expressions. Exponent, again, can take any two math expressions. And number is the recursion stop condition where, okay, I know how to calculate number. So how can you calculate sum? I evaluate both sides and then I sum them. How do you evaluate exponent? I evaluate both sides and send them to pow function. I think that you can say that what we don't like here is the allocations. I mean, why should you have allocations? And also the non-symmetric calls to a new and delete. There is 5 calls to new, I think. 1, 2, 3, 4, 5, and only 1 to delete. There isn't any leak because there is a tree here held by expression pointer E. And once you delete E, E deletes cascades the deletion to all the arguments that it holds. You don't have to dive into the idea of the example, but we don't like allocations in modern C++. So instead of allocations, we say, okay, you know what? We will handle the expressions in another way by holding smart pointers, okay? So the user code may look like that. Make unique sum, then make unique exp, then make unique number, then noise, noise, noise. And this is too noisy. I mean, yeah, eventually I do want to hold unique pointers, but why should I bother the user with these internal implementation details? Maybe later on I will decide to, I mean, if I decide to use shared pointer inside, it will still work because shared pointer can be converted into, if you create unique pointer in user side, it can be converted in my side, in the library side, to shared pointer. But let's assume that I encourage the user to use shared pointer, and then later on I decide to use in my class unique pointer, then it is an issue. So the question is, why should I tell the user that I'm managing things here with unique pointer, and this is the way that it looks like. I mean, the user in a way, knows that the entire thing is working with unique PTRs. A much better approach would be to hide both the hierarchy and the need to use unique PTRs, which would look like something like that. I mean, call something which would be eventually a factory method, or a constructor that creates our value, and our value is being sent to another constructor and then being moved into a unique PTR. But the idea that the class is managing a type A, and if type A is complicated, or something that you may change later, or something that user don't have to know about, then I don't have to expose it as, oh, you have to send me type A as my argument. No, just create what I want, what I need. So I would prefer this approach. Why is it better? I don't know, compared to the previous one, it is much easier, and it preserves the liberty of changes at the library side. Hiding your implementation details. The user doesn't have to know that we use unique PTR. We may want to change it later, maybe to another type of smart pointer. It's a private implementation detail and it is noisy. The link to the talk given at cppcon is there, and also the code. So you can watch the entire flow from working solution, but a design which is quite noisy. By the way, this is not the end point of the game. In the talk, I take it later on to all templates without any polymorphism. So it starts with dynamic polymorphism and ends up with the entire tree. The entire hierarchy can be expressed based on templates without any polymorphism. Hiding inheritance hierarchies is something that we know from design patterns. State pattern. Employee is an employee. If our code needs to work with an employee, it would be much better. It's a universal message. I mean, employee is an employee. Why should you care if this is a subcontractor or internal employee? I mean, why should you get employee pointer just because maybe we have inheritance and we have different kinds of employees? Why should you have different kinds of employees? This is implementation detail. What makes it implementation detail that can be hidden? Which design pattern? State pattern. I mean, eventually it would be much easier to write code where employee is an employee and hide the fact. Hide in a way that maybe you can inquire this, maybe you can change it, maybe a subcontractor can become an internal employee, which means changing the state. Changing something that is being managed, by the way, in the private section. Why it is much better than holding a type for subcontractor and a type for internal employee? Because this transition is quite common. And once you come to a subcontractor and you said, we decided that we want to hire you, we talked with the company and everything is fine and everybody is happy. But there is one small thing that you have to know. In order for the thing to happen, we have to kill you and then we have to revive you, okay? Are you sure? Yes, usually this is what we do and usually it works. Okay, let's do it. Let's kill you and then recreate you. Now, killing you and recreating you sounds like, okay, just for, no, it's actually what happens in code, which is buggy. Why? Because maybe in some places in code, there is a pointer to the previous employee. The pointer would be dangling. So I need to make sure that while I do the transition, it is not held by anyone. While if I would hide this state thing, you would just, remain the same employee. You're the same guy that we like, even that you became internal employee. Your subcontractor friends will still go with you to lunch occasionally, but they need the right pointer. They need to be able to locate you. Your email. It might be that if you change the type by killing and recreating, you will change your email. Why? Because there is a certain point where the old one is still alive. You create a new one and you copy the fields, which is, by the way, costly. I mean, performance-wise, you need to copy fields that are managed in the base class. And then one of the fields that you want to copy is the email. And then IT department says there is an issue because once we copy the email, the old email is still in use because we are still alive. So we need to give you a new email. We just add the number 2, okay? So all the emails will be deleted, you will get new emails. Yeah, things like that happen. Why? Because this is how the system works. Can the system work otherwise? Yes. Design it better to begin with. So state pattern in a way hides implementation details that should be managed. I mean, the details are there, but they should be hidden. It's not what actually matters for me when I hold employee. I just want to add an employee. Strategy pattern. Why should I care if a pathfinder is a BFS or DFS? I mean, this is a pathfinder. I just want to write code for pathfinder. And if for some reason the pathfinder changes the strategy in runtime, for some reason we realize, okay, we prefer now at that point to move to another strategy. Why should I kill the object and create a new one? This is why we use strategy. In a way, we hide the algorithm or the policy that we use because it should not matter for the user. I mean, it might be that the user would not misuse it, but it is noise. And we pay for maintaining this noise. And the same thing is for factor method. I want to create something, go to the factor method, create something, get back something without knowing what it is. Why? Because not knowing is valuable. I mean, it's good that you do not know. You just know that it is an employee, or you just know that it is a shape. Which kind of shape? You shouldn't know. I mean, you should work with this shape as a general shape. Now, if you would create it as a circle, maybe in the next line you would do something knowing that it is a circle, and I don't want you to know. And I actually don't know, I don't want you to know which type is being created, because the logic of what type we are creating is something that might be changed. And this is, again, private implementation detail. What actual type do you want to create with these arguments? Oh, I have some logic in a big function. No. Send it to a factory, which this is its only responsibility to create a proper class. So we do want to hide the inheritance and details about it. Conveying less information on return values. What do you say about this function? I have a function that returns a vector. By the way, is it a dangling vector or is it fine? It's fine. Is it costly? No. Move semantics. Maybe even RVO. What do you say about the API? Reveals too much information. I mean, if later we would decide not to return vector, what else can be returned from the function with the same semantics in a way? A list, a std array, right? I may return something else. So maybe this one. What do you say about this one? I mean, that's a nice cheat, right? If you see something like that, what do you do? Go to the function and check what does it return. And it returns a vector. So it is very similar to writing that we return a vector. I mean, I don't have any other choice but going to the function or hovering with the mouse and seeing, oh, okay, the return value is a vector. Okay, so let's go with another approach. Anybody with an approach? I mean, we talked about the approach when we talked about arguments. It's quite the same. So we can go with return a concept. Here the concept would be a bit less safe than using it for an argument. And the reason is, when we talked about concept, and we said that Dave Abraham said that this morning, concept checks that what we actually send obeys to the concept requirements. But it doesn't check that the consumer is using only what the concept allows. The user actually can use anything that is on the actual type that was returned. Now, when it is on an argument, like in the previous example, which I'm still not so happy with, I prefer using a wrapper or interface. Interface would be stronger, or wrapper. But when it is on an argument, I can say that, you know what, we will test it with something that provides only the allowed functionality. And then if inside the function you do something which is not allowed, we will catch you in testing. On return value, it's a bit harder because eventually you return vector. The function return vector. Can I? Yeah, you can stub. You can mock it, but mocking it means that I want to check the function, but I mock the function. I don't know, it's a bit problematic. So eventually I have a function that returns vector, but reveals to the user, exposes on the signature that the return value is a random access range of ints. By the way, there isn't any concept like that in the language. It's not an existing concept. It is created in the code link below by using a concept and a type trait. A concept that T is a range, and then checking that the range value type is int or is T. Okay, so this is how I created random access range of, and then it actually allows, or the user would not, should not assume that this is a vector. The user should assume that this is a random access range of ints. And again, if the user actually uses that as a vector, code would compile. So if you are concerned about that, go with a wrapper or interface, which goes back to using as a return value a concept. First, it is since C++20. It is only on functions implemented in the header because it is out. It should be auto-deduced. The compiler needs to deduce it, so the implementation should come with the signature, and the compiler doesn't check the usage. Slide 60 on Dave Abraham's talk. I added that this morning. The other option is interface. So I can provide back from the function an interface that actually exposes only the things that I allow you to use. And the actual type should inherit from the interface. It wouldn't work for vector because vector doesn't inherit from my interface. But it can work with other types that I have. Okay, let's assume that I have a type called big common struct. It might be that you should not get back common struct. Okay, I send it back and you get another interface pointer or reference that allows you to use only the functions that I allowed. Of course, you can always go to the function, see what the function actually provides, and then you can always do, if you are downcast, if you are eager to use things that you are not allowed to, you see the interface, you go and check what is the actual type that is being provided, and you can always do downcast. But then you are a criminal. I mean, we will catch you at a certain point. You do something that you shouldn't. I mean, I want the code to protect people who just use the code as is. I mean, I got something, I used what I'm allowed to use. I mean, the function is there. You cannot tell me don't use it, but it is there. Oh, so maybe I shouldn't give you this function. And the last option is a wrapper class. But as we saw before, it's a bit more work. Because even if it's just an interface, you just have to, in the interface, you just have to declare the pure virtual functions that you want to support, right? And the actual type would implement them. If it is a wrapper, then you have to implement the delegations, which is not so costly. I mean, it's a bit of a work, but it is doable, and we should do it. And we don't do it enough. Beware of leaky abstractions, because in some cases we do return some wrapper, or we do return some proxy, and the proxy in a way exposes not what we do not want to expose, exposes the behavior of the proxy, the specific behavior of the type that you created to hide the implementation. Can you have an example of something that hides something, but then in a way exposes something that, or things that we do not want to expose? Oh, it behaves like that. Oh, do you have an example? Vector of Booleans, of course. Vector of Booleans, when you want to get an item from a vector of Booleans, you actually get a proxy, right? But that's fine. It hides the idea that vector of Booleans is holding the Booleans inside bits. But then it cannot return me a bit. It's a bit complicated to return a bit. So the idea is it returns a proxy that knows which bit is being represented by this proxy. And then when you work with the proxy, the bit can be changed. Okay, nice. But it comes with certain peculiar behaviors that we want to avoid. So maybe it is not the best idea. So when we do work with, oh, I actually returned something else, make sure that the something else behaves nicely. I mean, as I want it to behave. Now, the wrapper that we saw for the map should behave nicely. You should eventually just, implement the functions that you want to expose. Hiding helper functions. Let's take an example where we have thingy with two functions, foo and bar. Now, you shouldn't call bar if you didn't call foo. And it is documented, but people will call bar before calling foo. We know that at a certain point, okay? How can we enforce that? I mean, there is some kind of private implementation detail that is exposed to the user. And it is, we actually expose helper functions and not the flow that is allowed, not the flow that we want you to use. Easily, just, that's easy. Just have a foo bar. Okay, it doesn't cover all cases because maybe you wanted to call foo and you did not want to call bar. We still want to allow you to call foo. It should be valid. I'm calling foo, but I'm not calling bar. But if I do want to call bar, I should call foo before. Okay, we can still do that in many options. I mean, there are more than two options that I will show. So another option might be, okay, let's make it a bit complicated. I have a foo bar, will send me a function, callback, I will call foo, then I will call the predicate, then I will decide whether to call bar or not. Okay, might be. Okay, if it serves your purpose, but I will tell you what for sure doesn't serve your purpose. To expose foo and bar. This doesn't serve your purpose. Don't do that. Another option proposed by Jonathan Story, sitting here, come to his talk on proteins and gRPC on Friday. We were discussing this example and he gave, we have another option for that. You can have foo return a token that with this token, you can call bar. So when you call, you have a foo function. I changed the inner foo to be called the inner foo, the private one. But then foo actually has here a private struct inside, and the struct points to thingy and has a bar function and calls bar. So when you call foo, you get back, you actually call inner foo inside, and then you get back the token. So with the token, you can chain the calls and do a call to a foo and then call to a bar. You cannot call bar without calling foo because you don't have the token that allows calling bar. Now one can say, but then maybe there will be a dangling pointer because maybe I called foo, I took the token, held it somewhere. We're in C++, dangling pointers can happen. You should avoid that somehow. Maybe with static analysis, sanitizers. API should be hard to misuse. This is the bottom line. Don't expose things that will allow user to misuse the API because people will misuse that. Using protected. What do you say about using protected? I don't like it. You don't like it? Okay. There are people who like it. I will give you an example in the slide on somebody who likes it in the slide. So we have a parent and the child. The child likes the protected. The parent has a protected field wallet, and the child has a function, endless celebration, which can use directly the wallet. It works. I don't know if you want it. Now, it's not the exact metaphor for the real world, because in the real world, I mean, in programming, in classes, the subclass is not a different entity. The subclass is the entity which is the base class. They are the same. But you can see that as, they are the same, but they are managed separately. So I don't want the child, even though in this example, we can think about child and parent, which are separate entities. If you have a derived class, derived object, the derived object is the base object. They are the same, they are together. So why should I not allow you to use the privates or use the protected of the parent? Because it should be managed by the base class. And again, I think that it is a valid example, even though it is not the exact same, the metaphor is not so exact. Okay, what should be the better implementation? Don't use protected for data members, use protected for member functions. So the alternative should be much, much better. I do have a need money function called the need money function, which you can see is implemented correctly. And you can still have endless celebration, but you will call a function. Okay. You see the types that the function uses? Anyhow, this is a better approach. Okay. I would strongly prefer data members to be private. I don't see a reason for protected usually. I mean, it's quite rare that protected data member convinces me that, yeah, that makes sense. Prefer protected member functions over public. I mean, in some cases, we put something in the public as a function which should be in the protected. So member functions, prefer protected. Testing private behavior. In some cases, we have the need to test private behavior. I will not go through all the slides here because I'm not talking about testing, but I will divide the discussion between two things. If you just need to inquire a state, because the test says in this flow, the state of the object should be this and that. And the problem is that the state of the object is in the private. So there are tricks how to allow tests to check private fields or even to modify private fields. You may want to use these tricks. I would usually consider adding getters for these fields, because if the test needs to check this state, maybe you want to check this state in traceability logs. So it is okay to expose the state because I think that I need it in the test. Okay, let's expose the ability to read the state. When a test needs to modify private things which do not have the proper modifiers, I mean, the public API do not allow me to do that, I would say that the tested book is broken. I would say that you are trying to create a workflow, a flow in the test that you should create otherwise in a different way. Maybe even a flow that would not occur in real life. Maybe a flow that is broken or unstable. So if something is not accessible and the test says, I need it, maybe if you needed to inquire, I'm okay with that, not in order to change it. So there are a few slides on that. The bottom line is that you should be very careful about changing your API just because the test requires that. Maybe for reading, much, much less for modifying. Use a proper context for your code. Namespaces. Context in classes. You have to hide something, hide it in a proper namespace called detail or unnamed namespace in another namespace. You need to hide an enum, hide the enum inside the class. You need to hide a class. Maybe the class should be in the private section of another class. Should I need this type in the private section or in the public section? That's a question. Ask the question and get the right result, get the right answer. Last item. I owe you something. Do you remember? I showed something and said, we'll see how to do that. Private token idiom is going to solve the problem of the factory function with the make unique. Do you remember where the factory function make unique should call the constructor? The constructor was in the public. We want to put the constructor in the private because we don't want you to call the constructor. We want you to call the factory, but we cannot. Friend doesn't help here. We actually cannot. I mean, any way that you will try to do it will result with bad coding. So we keep the constructor in the public, but we do not want you to use the constructor. So we allow use of the constructor only if you come with a specific certain argument that you don't have. And this argument would be a private token. It has many names, and even a question in Stack Overflow, what should be the name for that? With many names. Access token pattern, passkey pattern. And the pattern is, I create inside foo. This is what we want to avoid. So we create a class private token inside foo, which sits in the private. In this case, the factory is inside our class. So the passkey is available in the class. But if the factory was outside in some other class, then we'd use friend, and friend would help in order to achieve the private key. Here, we don't need to use friend because the one that uses the private key is here, which is me. I'm creating the private key. It's not make unique. Make unique just needs the constructor. Yeah, the constructor is public, but no one else from the outside can call this constructor because it doesn't have, they do not have the private key. So private key token is a way to make sure that nobody would use function that is actually in the public for technical reasons. Used here, but maybe used in other cases as well. Let's summarize. Hiding your implementation detail is more than just a design recommendation. It will make your code more robust and maintainable. Less bugs. Easier to refactor. The user sees only what the user needs to see. You will get encapsulation and decoupling. I mean, we all remember that decoupling is important, and encapsulation is a key design approach in object-oriented. You need to strive for having that. Having private fields is not enough. It's mandatory, but not sufficient. Implementation details is context specific, something that should be public for a certain context. I mean, I do want to open the fridge and take food, but I don't allow the dog to do that. So don't expose those functions. It is context specific, because if they don't need it, you shouldn't give it. And you may have reasons for avoiding hiding implementation details. In 95%, the reasons are wrong. Just do it, okay? Don't be lazy. Look for things that shouldn't be exposed. And this will improve your code and save you time and money by preventing future defects and refactoring. And that's it, thank you. I think that I still have some time for a few questions. Yes, Tom.
Just core guideline, I look at the one by heart. C131, which is
You don't know it by heart, but you remember the number.
yeah.
Okay.
No, I remember the rule, but I did not remember the number. That says avoids trivial getters and setters, which seem to be in contradiction with the advice you give when starting a class. Can you comment on this?
Okay, so the question by Tom was, there is in the core guidelines a guideline saying, and Tom just gave the number of the guideline, but so C181, 31, 131. It reminds me the pub where people come and repeat the jokes day after day, night after night, the same jokes. So eventually they gave numbers for the jokes, so they would not need to repeat the joke. So they came to the pub and somebody said 25, and everybody laughed, and then 37, and so yeah, we can do that. About the recommendation of in the core guidelines, do not use trivial getters and setters. Avoid trivial. So I would say that if I have a member that I should not expose a setter, then you should not expose a setter. This is I would say trivial. But if I take, in some cases we take recommendations at their value phase, like, okay, we will not create getters and setters. How can we do that? We use struct. We just put the members on the public. So I would say, okay, start with putting your members in the private. Okay, so this would be a start. And then, do you need actual access to this member? What is the reason? Okay, maybe I do need getters and setters. If not, then I should not. It's a question. But eventually the question is, it depends on the context, again. In some context, I do allow you to modify. In other contexts, I do not. In some case, I do allow to modify this, but not that. How do I do that? I do not provide the same thing. Remember the big common struct of the student? So the idea, the master says, why don't you just provide X and Y? Providing X and Y is nice. But then someone can say, but X and Y would be just the beginning. Later on, I will realize that I need to provide also Z. So instead of adding one and another, I just provide the entire thing. We do that, right? It's not a good practice. Why? Because later on you will realize that you need to provide something which is not in big common struct, is in another struct. So we'll add that as well. So now we are sending two big structs to this function that doesn't have to know about these structs or these classes. So we can just create the type that I want you to use. And on that type, I believe that you will get getters. You need it. Maybe even this simple type will be a struct, because it's a type that you just need ad hoc. I just created the type that holds all the information that you need. Maybe the type will be a wrapper that holds a reference to the actual resources that you are going to use. And I expose only the public functions for you that I allow you to use. But inside, yeah, there are the 2 references or 3 or 1 that allows you to use it. The need for getters depends on the use. Thank you for the question. Another core guideline number or question, other question. Yeah, please.
Do you have any views on, say, if we had a function that took 2 doubles and the user could quite easily transpose those values? I remember Scott Myers used to say you could make it trivial plus
yeah. So
weekday or something that would enforce weekday being the first.
So the question was a function that gets 2 doubles, and mistakenly somebody would send the opposite doubles, right? How do I avoid that? And we all know that type safety allows for, if one double is longitude and the other one is latitude, maybe instead of getting 2 doubles, we'll use type safety, and we will have types for each one of the doubles. One is speed, the other one is distance, whatever. So I would go with type safety, and the industry is going with type safety. More and more projects are using, instead of pure numbers, actual types. And if the type, it might be the same type. You need to get distance and distance, one for X, one for Y. And you are still a bit worried that it's 2 distances. And I'm not just going to multiply them, because then the order doesn't really matter. I'm actually going to use them as X and Y. So maybe create a type called X and a type called Y, and there is a library called named type by Joe Bucara that you can use that can easily help you creating types by a template that just knows which type is being used and a tag name. So quite easily I have a type for X, type for Y, instead of with automatic, with casting back to type if I want. I would go with type safety. I didn't mention here because I think it is another safety advice, not related, I think, to keeping things hidden. I think that our time is up. I'm here for other questions afterwards. Thank you very much. Thank you again.